In this question, it is given that the point root 3 sine theta, root 4 cos theta, where theta is any real number, lies outside the hyperbola x squared by 4 minus y squared by 5 equal to 1. Here we'll have to find the value of theta. Let's begin. So it's given to us that this point root 3 sine theta, root 4 cos theta lies outside the hyperbola x squared by 4 minus y squared by 5 equal to 1. So when you say that a point lies outside a given hyperbola, you conclude with S1 being less than 0, the value of S1. The value of S here is x squared by 4 minus y squared by 5 minus 1. This is S. S1 is when you take the value of x as root 3 sine theta and y as root 4 cos theta. Put that into this equation. We'll have to say that S1 should be less than 0 for the point to lie outside the hyperbola. So here it's given that the point already lies outside the hyperbola. So let's put this point into this equation. What do we get? X square becomes root 3 sine theta the whole square, which becomes 3 sine square theta. So x square by 4 minus y square by 5. Y square would be 4 cos square theta because y is root 4 cos theta divided by 5 equal to 1. Divided by 5 minus 1 will be less than 0 because this point is already given to us as lying outside this hyperbola. So now sine square theta, I'll convert it to cos square theta. For that, I'll remove sine square theta and write that as 1 minus cos square theta. Now I'll make the common denominator 20 here. Now while I do that, what happens here? This becomes 15 minus 15 cos square theta minus 16 cos square theta minus 20 is less than 0. So from here, I can write this as, so the 20 goes off into the RHS when I multiply the whole thing by 20. And then I get minus 5 less than 31 cos square theta. And from here, I can say that cos square theta will be greater than minus 5 by 31, right? So we have cos square theta greater than minus 5 by 31. We know that cos square theta, alright, cos square theta is between 0 and 1. Okay, cos square theta will always be between 0 and 1 here. Now, it's given, what we deduced was that cos square theta is greater than minus 5 by 31. Let's compare both. We can see that cos square theta by default will always be greater than minus 5 by 31, whatever value of theta you put. So this is our conclusion from here, that theta basically can be any real number. So our final answer will be theta being any real number. As you can see, that is option A, and hence A will be my correct answer. In this question, it is given that for all real permissible values of m, if this given straight line is a tangent to the hyperbola, then we'll have to find the equation of the hyperbola here. Alright, let's begin. So we have our given line y equal to mx plus root of 9m square minus 4. Suppose it looks like this, and it's given to us that it is a tangent to this hyperbola. So we can see that this hyperbola here, in the options, we had hyperbolas in this form, x square by a square minus y square by b square equal to 1. And such hyperbolas have their center at the origin and transverse axis along the x-axis. So I assume this to be the equation of the hyperbola, and the tangent to such a hyperbola will be y equal to mx plus or minus root a square m square minus b square. Now it's given to us that this and this line are both the tangent to this hyperbola x square by a square minus y square by b square equal to 1. They are the same line. So let's just compare both. I can see that on comparison, a square is 9 and b square is 4. I get a square 9 and b square 4 upon comparison. M can take any value. Now, let's plug this into the equation of the hyperbola, because that is what I'm trying to find here. X square by a square minus y square by b square equal to 1. And we have a square equal to 9 and b square equal to 4. So this is the equation of my standard hyperbola. And in the options, we didn't see any denominator there. So what do we do here? Multiply the whole thing by 36. What happens here? I get 4x square minus 9y square equal to 36. This is the hyperbola I've been looking for. 4x square minus 9y square equal to 36 is option D, and hence D is our right answer. Got that? It's given that the chords of this circle x square plus y square equal to a square touches this given hyperbola. Now we'll have to find the locus of midpoints of these chords. Okay, so let's begin. So we are given a hyperbola x square by a square minus y square by b square equal to 1. And then we are given another circle x square plus y square equal to a square. And we know that the chords will have a midpoint whose locus we'll have to find. So we'll construct the circle x square plus y square equal to a square, and we are given the midpoint of its chord. What can we do with the midpoint of the chord? I can find the equation of the chord with that. How do I find that? I'll use the simple formula t equal to s1. So I'll assume the midpoint of the chord to be h comma k. Suppose it's h comma k because this is the point whose locus we'll have to find. How do you find t here? To find t, I replace x square with xh and y square with y1, or in other words yk. So then this becomes xh plus yk minus a square equal to 0 will be t equal to 0. Now we have t equal to s1. S1 comes out 2. So substitute the point directly into the equation of the circle to get h square plus k square minus a square. How convenient it is to cancel out minus a square. What do I get here? I get the equation of the chord to be xh plus yk equal to h square plus k square. So this is the circle. You can see the midpoint of a chord being h comma k. We just found the equation of the line, alright, of the chord itself. Now, what do we do here? So we have the equation of the chord here. So I'll write that in y equal to mx plus c form. Okay. So we know that the hyperbola x square by a square minus y square by b square equal to 1 will have tangent in this form, y equal to mx plus c, where c square equal to a square m square minus b square. Okay, so I'll write it as mx plus c, and this is the same format in which I write the line I have here, y equal to minus h by k into x plus h square plus k square divided by k. So this is what I get now. Alright. So this is in the form y equal to mx plus c. Why did I equate this? Because it's given to me in the question that this chord will be tangent to the hyperbola. So that's why I equated it in this form. And here I get c square equal to a square m square minus b square. I know that condition. So here, instead of c square, I'll take the constant term from the second part here. Okay. So this becomes h square plus k square by k, the whole square is c square equal to a square m square minus b square. Now compare both these equations again. You can see one more thing. M, the value of the slope, is equal to minus h by k. Substitute that here as well. So you get a square into h square by k square minus b square. We are heading closer to our answer now. Okay. So we are looking for the locus of the point h comma k, which happens to be the center of the chord. Okay. So I found the equation of the chord and equated it with the equation of tangent to the hyperbola, because it's given in the question that the chord is also tangent to the hyperbola. Let's proceed now. So we have with us h square by k square the whole square by k, h square plus k square by k the whole square equal to a square into h square by k square minus b square. I have this much with me. So I notice that the common denominator is there, k square. So I'll make it a common denominator for real. So this becomes h square plus k square the whole square divided by k square equal to a square h square minus b square k square divided by k square. So on both sides you can see it's divided by k square. I can simply cancel them out. Alright, they vanish. Now this is what I get. Now we have reached our answer actually. Just find h comma k and replace that with x comma y to get our final answer. So the locus of the middle point, the midpoints of the chords would be, replace h with x and k with y to get x square plus y square the whole square equal to a square x square minus b square y square. Let's check it in the options now. We can see that this is option A, and hence A will be my right answer. Got that? Take a look at this question here. We are looking for the equation of common tangents to two given hyperbolas here. Okay, so the given hyperbolas are x square by a square minus y square by b square equal to 1 and y square by a square minus x square by b square equal to 1. Alright, it's also given that a is greater than b. So since we're looking for the equation of the common tangent, I'll simply call it y equal to mx plus c. Okay, so for the first tangent, for the first one, what will the condition be? So to find the conditions, we'll simply compare with what happens with respect to an ellipse. Okay, so for an ellipse, x square by a square plus y square by b square equal to 1, the condition for the tangency would be c square equal to a square m square plus b square. I'll just compare and bring it across here. Okay, so this one, x square by a square. So here it's given that a is greater than b. That's why this will work out clearly here. Okay, x square by a square plus y square by minus b square equal to 1 is the first hyperbola. And the second one, I'll write it this way. X square by minus b square plus y square by a square equal to 1. Alright, so I've done this pretty neatly. Now let's bring in the conditions. So y equal to mx plus c is the common tangent. Okay, so the condition for the first part would be c square equal to a square m square. So instead of plus b square, you bring in minus b square from here. Okay, a square m square minus b square. We already knew this. Okay, let's apply the same approach to the second one. Second hyperbola here. So I can say that c square equal to, so instead of a square, I'll write minus b square from the denominator of x square. So it becomes minus b square into m square and then plus the denominator of y square. So here it is a square. Okay, so basically since I am looking at the common tangent as y equal to mx plus c, both the c values are the same. So you can equate both. So let's equate both. What happens here? So I get this as a square m square minus b square being equal to minus b square m square plus a square. Okay, so I'll take the a terms together. Sorry, I'll take the m terms together. I'm looking for m here. So m square into a square plus b square. I just take this to the LHS equal to a square plus b square. I know for a fact that a square plus b square cannot be 0. Both a and b have to be greater than 0 here. So the same thing will hold true for a square and b square. So I can say that m square is equal to 1 here, which means that m is equal to plus or minus 1. Okay, I have m equal to plus or minus 1. So what does that make c square? C square becomes a square. Okay, this is for the ellipse. So I'll just keep that aside. Now let's look at the hyperbola. So here we are looking for c square. C square is nothing but, for either of these cases, I get it as a square minus b square. Okay, so from here or from here, from either of these cases, I get c square equal to a square minus b square, which means that c is equal to plus or minus root of a square minus b square. Okay, we have this much with us. We have m, we have c. Let's bring it in. So I get y equal to mx, which becomes plus or minus 1 into x, plus c. C is plus or minus root of a square minus b square. These are the common tangents I've been looking for. That's it. We are done here. Okay, now let's proceed and mark the correct options. So the common tangent is option B, which is y equal to plus or minus x plus or minus root of a square minus b square. Got that? A tangent to this hyperbola x square by a square minus y square by b square equal to 1 cuts the ellipse x square by a square plus y square by b square equal to 1 at points P and Q. We have to find the locus of the midpoint of PQ. Let's begin. So we have a tangent and a hyperbola given to us. Alright. So we are given that a tangent of this hyperbola cuts through this ellipse at 2 points P and Q. We have to find the locus of their midpoints. So first let's look at the hyperbola, and the tangent to that hyperbola at any point x1 comma y1 lying on the hyperbola would be given by t equal to 0 or x1 by a square minus y1 by b square equal to 1. Alright, so this becomes the equation of our tangent to the hyperbola. Now this tangent here, as you can see, cuts the ellipse at points P and Q. So, and I'll call its midpoint to be h comma k here. So as you can see, there are 2 points at which it cuts, P and Q, and the midpoint is h comma k. We need to find the locus of this midpoint h comma k. Now, separately, consider an ellipse where the midpoint of the chord is given. Okay, where the midpoint of the chord is given. Can you find the equation of the chord? Yes, you can, using the simple formula t equal to s1. Okay, so where do we get t from? Replace. So h comma k is the midpoint of the chord that is given. So we will use that for t here. Okay, so x square by a square becomes xh. Write that again. X square by a square becomes xh by a square plus y square by b square becomes yk by b square minus 1 equal to 0 is t equal to 0. But we have t equal to s1. What is s1? That is h square by a square. Replace x and y with h and k. H square by a square plus y square by b square minus 1. Simply cancel out minus 1s to get the following equation. X into h by a square plus y into k by b square equal to h square by a square plus k square by b square. This is the equation we get for the chord with midpoint h comma k. Now, both are the same, aren't they? Okay, so we got these two equations. One is tangent to the hyperbola, and it's given to us that this tangent cuts the ellipse at 2 points P and Q, whose midpoint we have taken as h comma k. So basically the idea is both are the same. Okay, so since both refer to the same line, I can equate the coefficients for each part. Okay, so the coefficient of x will be x1 by a square. Okay, so this is divided by, so x1 by a square is divided by h by a square. H by a square. This will be equal to minus y1 by b square from the top, which is the coefficient of y term. And then here, the coefficient of y term will be k by b square equal to, the constant term is 1. And in the below equation, the constant term is h square by a square plus k square by b square. Alright, so we have this much with us. I can cancel out a square, b square from the first two parts. And I can say that x1 is equal to h by h square by a square plus k square by b square. And I get y1 equal to minus k divided by h square by a square plus k square by b square. Okay, I have x1 and y1 like this. Why did I do that? Because I know that the point x1 comma y1 will lie on the hyperbola. So the hyperbola is x square by a square minus y square by b square equal to 1. So I will convert that into x1 square by a square plus y1 square by b minus y1 square by b square equal to 1. Why? Because this point lies on this hyperbola x1 comma y1. Okay, x1 comma y1 lies on this given hyperbola. So Now what does this become? This becomes h square by a square plus k square by b square, the whole square, divided by a square minus y1 square, and that will become k square by, again, h square by a square plus k square by b square into b square equal to 1 here. Okay, so we have this equation with us. Let's proceed from here. And you see this almost common denominator, I'll bump that up to the numerator of the RHS. So this becomes h square by a square minus k square by b square equal to h square by a square plus k square by b square, the whole square. Alright, so here I didn't mark this out. K square by h square by a square plus k square by b square raised to 2. Okay, this will be multiplied by b square in the denominator. So that is what I take common to the RHS. What happens here? So I'll simply replace h with x and k with y to find the locus of h comma k. I'm trying to find the locus of h comma k. That's the final target. So this becomes x square by a square minus y square by b square equal to x square by a square plus y square by b square, the whole square. Alright, this becomes the locus of the midpoint of P and Q. Alright, now let's move ahead and mark option A, which is our correct answer. Got that?